Welcome. This is a video on rounding and significant figures. So we're going to start with just a little bit of rounding, not too much. But so remember from back in the day when you first learned to round that if you are looking at numbers 0 to 4, you round down. And by rounding down, it means really you're just staying the same. So 0 to 4, you stay the same. And 5 to 9, that's right, the top half, so we round up. So those are kind of your big rules when rounding. So when we look to round, if you look at number 1, round 875 to the nearest 100. Well, first you have to recognize place value. So the 8 is in the 100 spot. We always look to the place to the right. So we're going to look at that 7. Because 7 is bigger than 5, we round up. So we're going to go up, and that means round to the nearest 100 would be 900. When you look at number 2, still going to the nearest 100. So 5 is in the 100 spot. I look 1 past that at the 4. 4 is less than 5. We round down. Rounding down means you stay the same. So the 5 in my 100 spot stays the same, and I just have 7,500. Let's go to a different place. Let's go to the nearest 10. All right, so think, which spot is in the 10s? So we've got, just for place value real quick, 1s, 10s, 100s, thousands. So if I want to go to the nearest 10, I'm looking at that 5. We look 1 past, which is 6. 6 rounds up. So I am at 1760. Oh my gosh, but if you look in your packet, I miscomposed those numbers. So in the packet, it's 1765. I apologize. Nearest 10 is 6. If you look 1 past at the 5, 5 still rounds up, we'd be at 1770. So, hey, you got a bonus problem. And number 4, round to the nearest whole number. Well, we have decimals here. So the nearest whole number would be a 3. Look 1 past at the 1. 1 rounds down. So nearest whole number would just be 3. All right, so there's our little review on rounding. Let's go ahead and look at significant figures. And I think this is something that's not really very well known. We don't spend a lot of time on it in most math worlds, I don't think, at least not at the lower levels. So probably in high school, middle school, you probably didn't really talk about this much. So significant figures. Any non-zero number is significant. If you have like a 1 and a 3 and there's a 0 in between, so this is a second piece, zeros appearing between two non-zero digits are significant. When we talk about decimals, if they are on the left, zeros on the left, they are not significant. On the right, they are significant. We'll look at examples of both of those. And if you do not have decimals, zeros on the right could be significant, but they don't have to be. So that can get a little bit confusing. Hopefully, you have good directions in the problems that you're doing, and they'll tell you how many significant figures you should have and that sort of thing. So we'll do a couple together, and then I will cut you loose and ask you to try a few. But first, let's look at just some examples. Given number, see how we're looking, comparing the given number, and then it tells us how many significant figures. So the first two I think are pretty easy. 4 and a 7, there are 2 non-zero digits, so there are 2 significant numbers. Same in the second one, 1, 2, 3, 6 numbers, so 6 significant figures. If you look at the third one, see how that 0 is in between 2 non-zero numbers, that makes it significant. And in the last one, we do not have a decimal, and we have 3 trailing zeros. So, depending on your problem, you could say that this only has 2 significant digits, the 3 and the 5. Or you could say it's got 3, you could count that, before it could be 5. So it has at least 2, it could be more. Some more examples, you'll see in the top one, the zeros are in between, so they have to be significant. In this next problem here, notice how we have a bunch of zeros at the beginning. Those are not significant. So we only have 3 significant digits, the 3, 1, 4. But in the next one, that 0 is at the end, so it is significant. So we've got 4 significant digits. And then a little bit in this last one. See how this last 0 is underlined? That's telling you that's your last significant digit, and therefore you have 4 total. All right, so looking at those examples, on this next page we've got 6 numbers, I would like you to just recognize how many significant figures. So go ahead and hit pause, write down how many significant figures you think each has, and then we'll come back. All right, so here's the significant figures. The first two I think are pretty straightforward. The first one does have a 0 in it, but because it's between two non-zero digits, it is significant. B has all non-zero digits. C is where it gets a little bit tricky. You will see that it's got 3 because of the 0 to the right, which is significant, but those zeros to the left are not. So we only count the last 3 digits. D and E, the zeros are between, so they must be significant. And then in letter F, you will notice that the 0 is underlined, saying that is our last significant digit, and therefore we have 3. All right, so what happens when we do some calculations, meaning multiply, divide, adding, and subtracting? Well, when you multiply and divide, your ending result, and you should not round until the very end. So your ending result will have the number of significant figures and the least significant numbers. So when you look at the numbers that we're starting with in letter A, we've got 3 significant figures here and 4 here. So when I find my answer, I want to round it to 3 significant figures. Okay, so we're going to go ahead and multiply it. And when I multiply these two numbers, I get 29.516. Well, I want 3 significant figures. So non-zero numbers, so my answer is going to be approximately 29.5 because that is the least significant. When I go to letter B, same concept. I've got 2 significant figures here and 3 here. So my final answer will have 2 significant figures. So when I divide 1.2 divided by 3.46, I get 0.34682, and it goes on and on. I only want 2 significant figures. So I want these 2, but notice that 6 rounds up. So my final answer should be 0.35. I probably should have said that up in letter A. If we would look one past at that 1 rounds down, and that is why our answer is 29.5. Apologize for that. And last, adding and subtracting. So adding and subtracting is about precision. So when you think about being precise, the longer a number comes out in terms of decimals, that's more precise. So just in looking at these, you can see the middle one is just to the nearest tenth, 0.6, whereas this last one goes to the nearest 10,000ths, 0.1234. So this is the most precise. Okay, well, if you look at the directions when you're adding and subtracting, you want to round your answer to the least precise. So because the 10th is the least precise, at the end I will round to the nearest 10th. All right, so when I add those 3 numbers together, I end up, well, I guess you're subtracting in there a little bit. I get 81.7066. And so because I want to go to the nearest 10th, the 10th is the 7. Look past 0 rounds down, so I'm at 81.7. And that is a quick review on rounding and significant figures.